Hi, I'm Don Humbert. I work with the high voltage team in analog power and interfaces products for MEMS and piezo drive. We're here today to talk about drivers for silicon or MEMS mirrors used to steer lasers or laser beam steering. These are used in a variety of applications, both for projection and data collection for different uses, and we'll talk about some of those here today. Our first example is projection. The lasers can be used either single or multicolor RGB to do simple raster or vector graphics projection, as well as HD quality imaging with the right configuration. Here we're just showing a basic raster and vector graphic projection example. These applications can include advertisement in a commercial environment. It can include infotainment projection like they do often in cars where they're projecting greeting images to drivers or safety messages, and also extend over into practical industrial applications such as projecting keep-outs around a moving robot and things like that. Our next example involves collection of data by interrogating a device with a laser and measuring the reflected information from that to create a point cloud field of information about the object. This image can be rotated and analyzed three-dimensionally and can be used to verify if manufactured item for things like screw hole placement, size, object dimensions, whatever needs to be checked. So it's heavily used in industrial applications, automotive being one. The static example we just talked about is an example of what's called metrology, where you're taking a static or fixed image of a device with the laser. You can now extend this and take continuous measurements from the laser using the same technique where you're interrogating with the laser and looking at the reflectance. An example of that would be the laser and receiving sensor, which are located above us. With a top-down look at this data, you'll see we create a cloud field where this is the source point, and you can see the two-dimensional version of the data extending out from that source point. This data can also be viewed three-dimensionally. As you see here, we're rotating it and able to see a three-dimensional representation of what's behind us in this environment. These solutions are brought to you from a cooperative effort between Microchip Technology and Miracle Tech of Northern California from Berkeley. Miracle Tech develops silicon mirrors and provides the firmware and system integration and end product focus for these demo systems. Microchip provides the components, drivers, microprocessor support, power management components, and other analog peripherals as needed. Thanks for watching.